Okay, so this is section 6.6, the answers. Got the question written up at the top, and obviously a screenshot of the calculator. N is 18. Probability of a success 0.30. Estimate the probability of exactly 6. P6 means exactly 6. These, I think, are the easiest ones because you take your 6, you subtract 5/10, and you add 5/10. It's everything that's in the middle. Mu is found by multiplying n times p. You know what n is, you know what p is. And then the standard deviation is the square root of n times p times q. Well, if n is 0.30, then it makes sense that 1 minus 0.30 is 0.70. You could have used 0.3 or zero point 0.7. Hit paste and 0.9137. I'm not sure what letter that is. Okay, that's number 7. Number 8, n is 20. P, probably of a success, 0.60. Fewer than 8. All right, so fewer. That means we're going to our left. Things are getting smaller instead of getting larger. Fewer than 8. Fewer than 8 does not include 8. So what you're doing is you get 7.5 marked on your horizontal axis and 8.5. Well, you're going to your left. Fewer than 8 does not include 8, so you got to start at 7.5 and go all the way to your left. All the way to your left, obviously, is E99. One of these two. The only time you're not going to have E99 or negative E99 is if you're doing exactly, because then it's going to be, 5.5 and 6.5. It's in between. So if you're using lower and upper and you've got a whole number, you haven't performed continuity correction, which means to add and subtract 5/10. Here again, fewer than 8 does not include 8, so I got to start at 7.5, and go to my left. The mean, the standard deviation, straight away, n times p, and then the square root of n times p times q. If the probability of a success is 0.60, then the probability of q, not a success, the complement is 0.40. And the answer came out to be 0.0200. Number 9, here's what I call the easy ones, exactly 43. You've got between 42.5 and 43.5. You know how to do the mean, n times p, and then we're talking births, so they didn't tell us the probability, but we know from way back when, probably of a boy and a girl is the same for our work. It's 0.5. Number 10, and what we got, multiple choice test consists of 60 questions. Each has 4 possible answers. Well, 4 possible answers, that means there's probability of getting it right is 1 chance in 4. Favorable outcomes over total. There's 4 total. Only one of those 4 is the correct answer, 0.25. And while I'm at it, if the probability of a success P is 0.25 and the probability of Q, not a success, is 0.75. But here's the deal. He says, estimate the probability of getting at least 20% correct. Well, if there's 60 questions, 10% is 6, 20% is 12. All right, at least 20%. So we're getting bigger. We're getting 12 answers right at 13 answers and so forth, all the way up to conceivably 60, all of them right. Now, the idea is at least 20, so at least 12. At least 12 is going to include 12. That's why I'm starting here at 11.5, because at least 12 has to include 12. And I'm getting larger. At least 12 would be 12 or 13 or 14 or so, and so forth. So I'm going all the way to E99. Mu is the n times p. We already figured out that probably the success of multiple choice question is 4 possible answers, 0.25, and then q was 0.75. So standard deviation is the square root of n, 60 times p, 0.25 times q, 0.75. So that one there was a little bit different. You actually had to find out what 20% was. In this case, 20% of 60 problems is 12 examples. Number 11, certain question on a test is answered correctly by 22% of the respondents. Estimate the probability. Among the next 150, there will be at most 40. So 41 is not good, 42, you're going to your left. Now, you've got 39.5 and 40.5. At most 40 includes 40. So I got to start here at 40.5, if I can get my thing here, 40.5. If I started at 39.5, I wouldn't include 40. Now, here's a question I see a lot. In the problem, it says at most 40, and then yet you see this over here, we're using 40.5. Well, that's because of continuity correction. Whenever you have a less than or an expression that translates to a less than or equal or greater than or equal to, you got to be on the other side of the number. And sometimes it doesn't coincide with what the problem says, but that's because of continuity correction. Don't freak out because this says at most 40, and here you're using 40.5. All right, once you use continuity correction, this here doesn't really play any sort of part in it. All right, don't get all bent out of shape because, well, it says at most 40. Why am I using 40.5? Because you have to for continuity correction. You're subtracting and adding 5/10. You're going to your left. At most 40 includes 40, so you got to start at 40.5, even though 40.5 is more than 40, what the problem says. That's because of continuity correction. You know your n is 150. He tells you the probability of getting it right is 22% of the respondents get it right. Well, if 22% of the respondents P is 0.22, then Q obviously is 1 minus 0.22, 0.78. I mean, finding mean and finding standard deviation, not the issue. It's getting the right lower and the right upper. But you have that common phrases that I actually posted. So number 12, a product is manufactured in batches of 120. There's my N. Overall defect rate is 5%. There's my P. Estimate the probability that the selected batch contains more than 6. Well, we're going to our right. We're going more than 6. The number is getting bigger. All right, so I got a line at 5.5 and a line at 6.5. Well, more than 6 does not include 6. So that's why I'm starting at 6.5. All right, because more than 6 does not include 6. So I got to start at 6.5. I'm going all the way to E99 as I usually do in a lot of these problems. He tells you N is 120 here. That was a no-brainer. He told you what P is 0.5. If P is 0.5, it makes sense that Q is 0.95. Square root of N times P times Q. Number 13, in one county, the conviction rate for speeding is 85%. Estimate the probability over the next 100 speeding summonses issued, there will be at least 90 and more. Well, at least we're getting bigger, so we're going all the way up to E99. I can kind of figure that out as soon as I can get this here. But at least 90 has to include 90. All right, so you got to start on the left-hand side of 90 at 89.5. Even though this guy says at least, because of continuity correction, we have to start at 89. At 89.5. So don't get this confused. Once you use continuity correction, sometimes this doesn't agree with it, but that's the idea of what we're doing. Mu is 100, N times P, 100 is N, P was 0.85, and then standard deviation, square root of N times P times Q. Well, P is 0.85, and we know that Q is 1 minus 0.85, 0.15. The probability, number 14, that a radish will germinate is 0.7. Estimate the probability that of 140 randomly selected seeds, exactly 100. I like these. These are the easiest ones, the exactly's. All right, I subtract 5/10 from 100, add 5/10 to 100. There's my low, there's my high. We know N is 140. We know probability P is 0.7. Therefore, Q is 0.3. Square root of 140 times 0.7 times 0.3. 2% of hair dryers producing a certain plant are defective. Estimate that out of 10,000 randomly selected hair dryers, exactly. Well, the easy one, exactly, is because I'm subtracting 5/10 from 225 and adding 5/10 to 225. He tells me what mu is. He tells me what N is, 10,000. P is 0.2. If P is 0.2, then Q is 1 minus 0.2 or 0.98. So this is the square root, sigma, the square root of N times P times Q. It looks like the same plant making these hair dryers. We still got 10,000 being produced. That's N. At least 219. So I've got to the left, I got 218.5, and to the right, 219.5. At least 19 means 219 and above. So I'm going to my right. So I'm going all the way to positive infinity. Now, at least 219 has to include 219. So I got to start to the left of 219, 218.5. Even though this disagrees with that, that's continuity correction. Don't get it twisted, please. 17, a coin is tossed 20 times. A person who claims to have extrasensory perception is asked to predict the outcome of each flip. She predicts the correctly 14 times. What's the probability of being correct 14 times? Well, 14 or more times, 14 or more. So we're getting larger. We're going all the way to E99 positive, E99 positive infinity. At 14 or more includes 14, so I got to start to the left of 14, which is 13.5. Now we're flipping a coin. Well, heads or tails, it's the same as like having a boy or girl. It's 0.5. You don't have to tell me what the probability was. P is 0.5. If P is 0.5, guess what? Q is 0.5. Now the probability here comes out to be 0.0588. I'm not going to follow up that question. Does this verify or claim? In statistics, in our textbook, probabilities that are less than or equal to 0.05 are called unusual. All right, so this is pretty darn close, but in actuality, it wouldn't be unusual. It's almost six. It happens 6% of the time, pretty close, that a person can guess 14, the heads or tails 14 or more times. All right, so this would not be, but I'm not gonna sweat that with you. I won't ask you, does this verify? Next one, same thing, same person, I guess, flipping a coin 20 times. And now we're finding out the probability that this person being correct 16 or more times. All right, 16 or more. So we're getting larger, 16, 17, 18, 19, and so forth. So I'm starting to the left of 16 because 16 or more includes 16. So I got to start at 15.5, go all the way out to infinity. There's my n times my p, and then square root of n times p times q. Now, this probability is so small, all right? So this is unusual. A person that can determine the heads or tails 16 out of 20 times, yeah, they would have some extrasensory perception, but I'm not going to hassle that. All right, this is unusual where this guy here was not under 0.05, so this is considered to be not unusual, but that's not the whole idea of what we're doing here, but I can explain it hopefully. Still tossing a fair die. All right, so we know probability of each face of a die is 1/6. Probably but 1 is a 1/6, a 2 is 1/6, all the way up to a 6, 1/6. So we want at least 30. Well, at least 30, we're getting 30, 31, and so forth. So we're getting larger. So I'm going all the way out to E99, positive E99, but at least 30 includes 30. So I got to start at 29.5. That's my lower bound. All right, I can't start at 30.5 because it wouldn't include 30. At least 30 includes 30. All right, so here again, it kind of goes against because at least 30. You know, well, why am I starting at 29.5? That's not at least 30. That's continuity correction, ladies and gentlemen. All right, probability. P times, he doesn't tell you what P is, but, going back, we know the probability of each number on a die coming out is 1 chance in 6. Guess what? There's 6 sides to a die. There's only one side that has a 5 on it, so it's 1 out of 6. So Q is 1 whole, subtract 1/6, Q is 5/6. There are 5 sides of the die that aren't the number 5. And number 20, find a probability. Here again, we're tossing this coin and a die, and at most 30. All right, so we're going to stop at 30. So we're going to our left. So that's why I have my lower limit here as negative E99. Now, at most, 30 includes 30. So if I'm going to include 30, I got to start at 30.5. If I started at 29.5, I wouldn't include 30. All right, so here again, this whole thing at most, but yet continuity correction, goes to 30.5. Don't sweat that. If you've done continuity correction, don't worry about it. It'll always happen when you have less than or equal to's or greater than or equal to's. It won't seem to jive with what the problem says, but that here again, once again, for the 9th time, is continuity correction. Hope this helps.